Module 1, Theoretical and Percent Yield. Overview of limiting reagent. In certain chemical reactions, one of the reactants is used until they are no longer available, while the other one can remain in excess. This is seen in precipitation reactions, as the reactant is used to form products until it is no longer available. The specimen which is completely used first is known as the limiting reactant. Another example could be seen in combustion reactions, where oxygen is at most times in excess. So as the limiting reagent is used up, the reaction will come to a halt. Therefore, it determines the completion of the process. So if you didn't quite understand, you may like this analogy. So for making pizza dough, you have 2 cups of water, 4 cups of flour, and 3 teaspoons of yeast. You need 2 cups of water, 4 cups of flour, and 4 teaspoons of yeast to make 2 full balls of dough. Unfortunately, you can only make 1 ball since you do not have enough yeast. In this case, the yeast will be the limiting reagent. So the quote-unquote reaction will end when the first ball of dough is made, since there is no more yeast. So in order to determine the limiting reagent, one must use the molar ratios of a chemical equation. We can use the example below. So with the sample data of reactant masses, convert to moles of the respective specimen. Finally, with the acquired moles, divide chlorine by phosphorus, and if the ratio is less than 6, chlorine is the limiting reagent, and vice versa. So since chlorine has more moles, it will be the divisor. If the ratio is bigger than 6, then phosphorus will be the limiting reagent. Other ways to find limiting reagent would be to divide the reactants depending on what a question is asked. If they give you moles or if they give you grams, you can divide the reactants respectively. So in the end, whichever is smaller will be the limiting reagent. Take 1. So theoretical yield. Theoretical yield is known as the calculated yield of a chemical reaction. It is determined by using pre-existing data to find a possible yield the reaction will produce. So in order to calculate the theoretical yield, the limiting reagent is needed since it determines the end of the reaction. The calculations will involve molar conversions. So this calculated yield is what is to be expected if the reaction goes until completion with no difficulty. This is somewhat of a formula for calculating theoretical yield. In a simple reaction, there will be a limiting reagent and the excess reagent which produces the product. So then to find the theoretical yield, you would need to convert X amount of limiting reagent to moles of product and then convert that to the mass of the product. This is a simple version of the actual calculation. There may be more conversions that need to take place before converting to the mass of the product. Actual yield. Opposite to theoretical yield, actual yield is the real data collected after a chemical reaction. So this data is usually found through experiment, either something that you've done yourself or data that's given in a question of a textbook or practice question in general. And the example on the right is a precipitation reaction, which is a general reaction which will result in a yield of sorts. So percent yield. Percent yield is the ratio between the theoretical and actual yield. It's determined by dividing the actual yield by the theoretical yield and multiplying by 100. In order to calculate percent yield, theoretical is needed to be determined. The result will be the percentage of how much the reaction observed yielded in comparison to the expected/possible yield. So simplified again, if we think back to the pizza dough example, we can apply it to percent and actual theoretical yield. So the recipe says that 2 cups of water, 4 cups of flour, and 4 teaspoons of yeast are needed to make 2 full balls of dough. The 2 balls of dough would be the theoretical yield, and the 1 ball of dough would be you were able to make would be the actual yield. Furthermore, if you were to calculate the percent yield by dividing the amount of dough you made by the amount of dough in the recipe, you would get 50% because the recipe calls for 2 balls of dough to be made and you were only able to make 1. So dividing 1 by 2 would create 50%. The importance. Theoretical yield describes the full extent of a reaction. How much product can be produced in an optimum reaction? If the percent yield is greater than 100%, then one can assume that there has either been an error in the calculations or there is an experimental error. But this has been seen in precipitation reactions that you may or may not have done in your high school chemistry career, where you may have gotten more yield than you thought you would have, and it would have been important to include this in your conclusions. So here we have a practice problem. If 35.4 grams of methane combusts with an excess of 56.1 grams of oxygen, what is the theoretical yield of carbon dioxide? So first you want to write out your chemical equation and then balance it. Next you want to write out all your masses and molar masses for methane, oxygen. So it's 35.4, 56.1, yada, yada, yada. Next, you want to write out the conversion from mass of methane to mass of carbon dioxide, since methane is the limiting reactant, because we know that oxygen is an excess. Therefore, methane is the limiting. So first, you want to convert the mass of methane to moles of methane to moles of carbon dioxide, and then moles of carbon dioxide to grams of the mass of carbon dioxide through molar conversions. So before sig figs, you have 97.1239 grams of carbon dioxide. So now we know, after sig figs, the theoretical yield is 100 grams of carbon dioxide. So practice question continued if we are still using the same data from the previous question. The question asked, determine the percent yield if the actual yield of carbon dioxide is 76.4 grams. So first, you want to write out the formula for percent yield, which is actual yield over theoretical yield multiplied by 100. Then you want to plug it in, so you have your actual yield 76.7 grams of carbon dioxide over the theoretical yield, which was 100 grams of carbon dioxide, and then you multiply that by 100, which should give you 76%. So the percent yield is 76%. So the reaction was able to reach 76% of its theoretical or proposed actual reaction potential. So in conclusion, the limiting reagent is the reactant which is used up first, which is needed in determining theoretical yield. Theoretical yield is the calculated product of a reactant. Actual yield is the product given from experiment. Percent yield is the relationship of reactants used in products made. I hope you enjoyed the tutorial. If you have any questions, I don't know what to tell you. Thank you for watching. Bye.